Hi, 8th grade. This is lesson 3 of module 11. Apply the Pythagorean theorem. The I can statement says, I can apply the Pythagorean theorem to solve real-life problems involving the legs and hypotenuse of a right triangle, including problems in 3 dimensions. So this first problem, number 1, will be just involving 2 dimensions, but then the next problem will be the 3-dimensional part of it, so you can see how to do that. So this lesson does not have a spark your learning, so they're starting right with the step it out, no build understanding either. So what I'd like you to do is read through this problem, A, B, and C, and try to answer these on your own. Take some time, pause the video, work through A, B, and C, and then we'll look at this together. So let's look at the step it out. Number 1, the red team and blue team are playing capture the flag. Each team places their flag in opposite corners, so you can see here's the red team flag, here's the blue team flag. The red team sends 2 players, Alfredo and Angelina, from the red flag, so they're going from here to try to capture this blue flag. Alfredo must follow the white arrows, so I want to show you it's kind of hard to see, but let's look at, this is a white arrow, and then this is a white arrow. So he's going this way from the red flag and then down this way along there. That's him following the white arrows. So the first question that they ask is, Alfredo how far does he run? So that's what they're asking you here. So they tell you that this side is 85 meters, so because this is a rectangle, this is also 85 meters up here, so he runs 85 plus this they tell you is 150 meters, so this is also 150 meters. So he runs 85 plus 150 meters, which is 235 meters. So that he runs 235 meters. So then they tell us that Angelina must follow the black arrow to the flag, so that's this one. She's running from the red to the blue also, but she's running just down that black line right there. Use the Pythagorean theorem to determine how far she runs, round to the nearest tenth. So if you remember, this is the theorem, the Pythagorean theorem. It tells us that the squares of the 2 legs should equal the square of the hypotenuse. So this longer end that's opposite the right angle, which would be here, is the hypotenuse. That would be your C. So a squared plus b squared equals c squared. So we're just using the information there, 85 squared plus 150 squared equals c squared. So they don't show you all those calculations, but 85 squared is 7,225. I'm just going to write it up here. And 150 squared is, let's see, I'll write it over here, 200 or 22,500. So that's b squared. This is a squared. So when you add those two together, you get 29,725. And so you want to take the square root of both sides. So the square root of c squared is c, and then the square root of 29,725, and they say round to the nearest, what do they say, tenth? When you actually calculate that out with a calculator, it comes out to be 172.40939, and it keeps going. But they say round to the nearest tenth, and then you look at this number next to it to the right, and that's a 0. So rounded to the nearest tenth, it's 172.4. So Angelina runs 172.4 meters. So then in C, they ask how much farther does Alfredo run than Angelina. All you're going to do is find the difference, which would be 235 minus 172.4, which equals 62.6 meters. So Alfredo runs 62.6 meters farther than Angelina. And that's all that is on this page. So let's look at the next page. So here are numbers 2 and 3. And the first part, they say the Pythagorean theorem. Let me is what we're looking at here, can be used to find lengths inside a three-dimensional object by finding right triangle relationships inside the object. And you can kind of see here in this picture what they're talking about a little bit, and then as you go through this, you'll understand a little bit more. And I also want to look at some of these words over here when we look at it together. So try to do numbers 2 and 3, 2A through E on your own, and look at number 3 also and try to do that, and then we'll come back and look at those together. All right, let's look at number 2 together. It says Jada wants to ship a 3-foot curtain rod to a customer. The biggest box at the post office is shown. Jada wants to know if the box is large enough to ship the curtain rod. So let's look at the information that they give us. The longest distance in the box is the diagonal AD. So that's this here, this from here to here. It forms the hypotenuse of this triangle kind of within the box. So this diagonal at the bottom, this height of the box, and then the hypotenuse is what we're looking for. I think this is a little confusing because they say that's 30 inches. I am going to color it a different color. They're actually marking the height is 30 inches. So that's this. So hopefully that helps. To me, it looks a little bit like they're showing the hypotenuse is 30 inches, but that's what we're looking for. It's not 30 inches. That's the height. So that's what we're going to put here. That height, because it's the same as DC. Oops, that's not going to work. Her pants are blue. So that's 30 inches as well, this height DC. And so then it says to find the length of AD, this hypotenuse that we're looking for, we must know the length of AC, this here on the bottom. That's what they are telling us, because that's the diagonal of the bottom of the box. We know the two sides are 12 by 12, so that should help us find that diagonal AC. So if we know that AC is the hypotenuse, we can use 12 squared plus 12 squared equals C squared. And so we know that's 144 plus 144, that's going to be 288. So C equals the square root of 288, which equals 16.97, so we'll say it equals approximately 17. So the length of AC is about 17 inches. Then it says in C, use the length of AC to find the length of AD. So hopefully what you did is you said, if I know this is 17 and CD is 30, so I can say 17 squared plus 30 squared equals C squared. So 1,189 equals C squared. So C equals the square root of 1,189, which equals approximately 34.5. The length of AD is about 34.5 or 34.5 inches. About how long is the longest rod that could fit in the box? So again, about 34.5. If you've ever mailed anything for real, you'd probably want it to be a little bit shorter, but that's the longest that you could possibly fit in there. And so they ask, can the curtain rod fit in the box? Why or why not? If you look back at what they say at the beginning, she wants to fit a 3-foot curtain rod, and you know that is 36 inches. So you would have to say no. And just for the sake of time, I'll let you write out why or why not. So then number 3, Kara measured the radius and the outside length of a ice cream cone. So here's the radius. Remember, that's half the diameter of a circle, and then the outside length right here. Then use Kara's measurements to find the height of the cone. So in this case, they give you the hypotenuse, and they give you one of the legs, and you're trying to find the other leg. So this I think you can do on your own. I just wanted to re-go over radius and height and show you that you were just finding the other leg. So in this case, you have one of the legs, and you're looking for the other leg, and you actually have the hypotenuse. So you could fill in 11.7 here, and then just figure that out. You're solving for B instead of C this time. So you're going to find the height of the cone in centimeters. So just because this is already long, I'm going to stop here. So go ahead and solve that and then do the on your own, and I will see you in the next lesson.